Hello everyone. Welcome to Swam's online lecture series on the topic database management system. Myself Mohammad Wadullah Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim University, Aligarh. I am pleased to have you join me today as we explore the fascinating realm of databases, and database management system. In the next few minutes, we will journey through data modeling using the relational data concept, relational model constraints, and integrity constraints. In the previous session, we have discussed some important concept of database management system, UML, relational languages, relational systems. Before proceeding with today's lecture, let me answer all the questions that I had given you in the last class. So the first question was, what do you mean by unified modeling language, and explain by detail. So as we discussed in the previous lecture, the unified modeling language is a standardized visual modeling language used to design, specify the document, software systems, specify and document software systems. It provides a set of graphical notations and symbols for representing various aspects of software systems such as classes, objects, relationships, behaviors, and interactions. UML diagrams, including class diagrams, sequence diagrams, and use case diagrams, allow software engineers to communicate and visualize system structure, behavior, and functionality in the standardized and consistent manner. Unified modeling language promotes better understanding, collaboration, and communication among stakeholders throughout the software development lifecycle, from requirement analysis and design to implement and maintenance. I hope now you will understand it clearly. Next question was, explain component diagram in detail. Now let's discuss the answer of question 2. A component diagram in unified modeling language represents the structural organization of software components and their dependencies within a system. It visually depicts the high-level architecture, showing how various components interact to fulfill system requirements. Components are modular, reusable units of software that encapsulate functionality and can be replaced or updated independently. In a component diagram, components are represented as rectangles with interface indicating how components interact with each other. Dependencies between components are shown using arrows, illustrating communication, inheritance, or other relationships. Component diagram aid in system understanding, modularization, and scalability, guiding developers in designing robust and maintainable software system in database management system. Next is describe benefits of package diagram. Package diagram in entity relationship diagram provide several benefits in database management system. Firstly, they organize entities and relationships into logical groupings or modules, improving the overall clarity and understanding of the database structure. Secondly, package diagram facilitate modular design, allowing the developers to divide the database into manageable units for easier development, maintenance, and reuse. Additionally, they promote better collaboration among team members. They clearly defining the boundaries and responsibilities of different types of database. Finally, package diagram supports scalability and extensibility. Finally, package diagram supports scalability and extensibility, enabling the database to evolve over time while maintaining its overall structure and coherence. The last question was, what is procedure query language? Explain in detail. Procedure query language is a type of database programming language that allows user to specify the step-by-step procedure for retrieving or manipulating data from a database. Unlike declarative query languages like SQL, which describe what data is needed without specifying how to retrieve it, PQL provides a structured approach to defining the sequence of operations needed to achieve a desired outcome. PQL typically involves constructs such as loop, conditional statements, and variables enable user to implement complex data processing logic within their queries. Enabling user to implement complex data processing logic within their queries. While procedure query language offers greater flexibility and control, it can be more complex and less intuitive than declarative languages. So, the agenda of today's lecture is to discuss some new and interesting concepts of database management system. These are relational model concepts, relational model constraints, integrity constraints. So, let us start the lecture with the detailed discussion of relational model concepts. The relational model in database management system organizes data into table or relations, with each row representing a unique record and each column representing a specific attributes. Key concepts include entities. In other words, we can say that a table, attributes, column, tuples, row, primary keys, unique identifiers, foreign key, link between tables, and relationship connection between entities. It enforces data integrity through constraints like entity integrity, ensuring each tuple is unique, and referential integrity, maintaining data consistency across tables. Relational algebra operations such as selection, projection, join, enable data manipulation. This model provides a flexible and structured approach to data storage and retrieval and foundational to modern database systems. A relational database management system. A relational database management systems data is organized into tables. Tables are similar to folders in a file system where each table stores a collection of information. Tables are further divided into columns and rows. Columns represent the attributes of an entity, while rows represent the entities themselves. A relational model is a powerful tool for organizing and manipulating data. However, it is also relatively easy to understand and use. Now we are able to understand what are relational model constraints. Relational model constraints in database management ensure data integrity and consistency, crucial for maintaining the reliability and accuracy of stored information. Entity integrity constraint guarantees that each tuple in a relation is unique, typically enforced by specifying a primary key. It prevents duplicate records, ensuring data uniqueness within a table. Referential integrity constraint maintains consistency between related tables, typically enforced through the foreign key constraints. It ensures that foreign key values in one table match primary key value in other table, preserving the integrity of a relationship between the entities. Additionally, domain constraint enforce domain constraints define reliable values for attributes, ensuring data validity and preventing the insertion of invalid data. These constraints collectively ensure that the database remains coherent and reliable, reflecting real world constraints and business rules accurately while preventing anomalies such as data duplication and inconsistency. In data modeling, the design of a relational database, we can put some restrictions like what value are allowed to be inserted in the relation and what kind of modifications and deletions are allowed in the relation. These are the restrictions we impose on the relational algebra. These relations, these are the restrictions we impose on the relational database. In models like entity relationship model, we did not have such facility. Database constraint can be categorized into three categories: implicit constraints, schema-based constraints or explicit constraint, application-based or semantic constraints. Now let's understand all these one by one. So the very first, constraints that are applied in the data model are called implicit constraints. Constraints that are directly applied in the schema of the data model by specifying them in the data definition language. These are called schema-based constraint or explicit constraint. Constraint that cannot be directly applied in the schema of the data model, we call these applications-based or semantic constraints. The another important topic of today's lecture is relational model constraints. The relational model constraints in database management system enforce rules on the data stored in relational databases, ensuring data integrity and consistency. Common types include primary key, foreign key, unique, and check constraints. Primary key constraints Primary key constraints enforce uniqueness of each row in a table, while foreign key constraints maintain the referential integrity between the related tables. Unique constraints ensure that the value in a column or combination of a column are unique, and check constraints enforce a specific condition on the data value. By, inform, by enforcing these constraints, relational databases maintain data quality, prevent inconsistencies, and uphold the integrity of relationships between data entities. ensuring accurate and reliable data storage and retrieval. These are the restrictions or set of rules imposed on the data contents. It validates the quality of databases. It validates the various operations like data insertion, updation, and other processes that have to be performed without affecting the integrity of the data. It protects us against threats and damage to the database. The second one is the domain constraints. Domain constraints in the database management system specify the domain constraint in the DBMS specify the allowable values for attributes within a database tables. They define the valid data types, ranges, and formats that each attributes can hold, ensuring data integrity and consistency. Domain constraints enforce rules such as data types validation, minimum and maximum value limits, and format requirements for character string or data, and format requirements for character strings or dates by, by enforcing by enforcing domain constraints. Database management system ensure that only valid and meaningful data is stored in the database, preventing data entry errors and maintaining the accuracy and reliability of the stored information. Moreover, these some other properties or features of domain constraints could be: every domain must contain atomic value, smallest individual units, which means composite and multi-valued attributes are not allowed. We perform data types check here, which means when we assign a data type to a column, we limit the value that it can be contained. For example, if we assign the data type of attributes age as int, we cannot give its value other than int data type. Now let us understand what is the key constraint and unique constraints. Now let us understand what is the key constraints or unique constraints. Key constraints, also known as unique constraints, play a vital role in maintaining the data integrity with a database management system. They ensure that specific attributes or combination of attributes in a table are unique, thereby preventing duplicates or redundant data. A primary key constraint is a type of key constraints that uniquely identifies each record in a table, ensuring that no two records have the same value for a primary key attributes. It serves as the main identifier for the table and facilitate efficient data retrieval and enforcing in a relational database. Alternatively, unique key constraint enforce uniqueness on the attributes other than the primary key, allowing certain fields to have unique value but not necessarily serving as a primary identifier. These constraints help maintain data accuracy, prevent data anomalies, and uphold the relational model's integrity principles by enforcing relational models integrity principles by enforcing uniqueness at the attributes level within a table. The other properties may include that these are called uniqueness constraints since it ensures that every tuple in the relation should be unique. A relation can have multiple keys or candidate key In other words, we can say minimal super key, out of which we choose one of the key as a primary key. We do not have any restrictions on choosing the primary key out of candidate key, but it is suggested to go with the candidate key with less number of attributes. The null value are not allowed in the primary key, hence not null constraints is also the part of the key constraints. In the above table, EID is the primary key and the first and the last tuples have the same value in ID, that is 0, 1. So it is violating the key constraints. The another very important constraints in database management system is entity integrity constraint. Entity integrity constraints are fundamental rules in database management system that ensure the uniqueness and validity of data within a table. They primarily focus on maintaining the integrity or individuals, entities, or records with a table. The most common form of entity integrity constraint is the primary key constraints, which mandate that each tuple in a table must have a unique identifier. This identifier, known as primary key, serve as a unique identifier for each entity, ensuring that there is no duplicate records within the table. By enforcing entity integrity, database management system prevents data redundancy and ensure data consistency, facilitating accurate data retrieval and manipulation. Violation of entity integrity constraints result in error or anomalies such as duplicate records, which could compromise data accuracy and reliability. Therefore, enforcing integrity constraint, therefore, enforcing entity integrity constraints is crucial for maintaining the overall integrity and quality of the database. Entity integrity constraints say that no primary key can take a null value, since using the primary key we identify each tuple uniqueness in a relationship. Entity integrity constraints say that no primary key can take a null value, since using the primary key we identify each tuple uniquely in a relation. In the above relation, EID is made the primary key, and the primary key cannot take null value, but in the third tuple, the primary key is null, so it is violating entity integrity constraint. And finally, the last constraints is referential integrity constraints. So the referential integrity constraints are represented. So the referential integrity constraints are essential rules in database management system that maintain the consistency and accuracy of relationships between tables. These constraints ensure that references made between the tables remain valid and consistent. The primary mechanism for enforcing referential integrity is through foreign key constraint. A foreign key is a table. A foreign key in a table refers to a primary key or unique key in another table, establishing a relationship between the two tables. Referential integrity constraints mandate that every value in a foreign key column must match a value in the corresponding primary key column of the reference table or be null. This prevents orphan records where reference point to non-existent data. Enforcing referential integrity helps maintain data consistency and prevents data anomalies such as orphaned records or inconsistencies in the related data. It ensures the accuracy and reliability of the database by preserving the integrity of relationship between entities. Now let's understand it with the table given on the screen. The referential integrity constraint is specified between two relations or tables and used to maintain the consistency among the tuples in the two relations. This, this constraint this constraints is enforced through a foreign key when an attribute in the foreign key of relation 1 has the same domains as the primary key of relation R2, then the foreign key of R1 is set to reference or refer to the primary key of relation R2. The value of a foreign key in a tuple of relation R1 can either take the values of the primary key of some tuples in the R2 or can take null values but cannot be empty. In the above table, the D number of a table 1 is the foreign key and D number in table 2 is the primary key. D number 22 in the foreign key of table 1 is not allowed because D number 22 is not defined in the primary key of a table 2. Therefore, referential integrity constraints are violated here. This is a good example.